Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm Victor, and with me as always is the brilliant Sheila. Today, we're diving into an important topic in the world of threads, threading issues.
That's right, Victor. Threading is a powerful concept in operating systems, but it comes with its own set of challenges. Today, we'll explore some of the key issues that arise when working with threads.
Let's start with the basics. Sheila, can you give our listeners a quick overview of what we mean by threading issues?
Certainly, Victor. Threading issues are the challenges that come up when we use multiple threads in an operating system. These issues can affect how well our programs run, how reliable they are, and how complex they become.
Excellent explanation. Now, let's dive into some specific threading issues. One of the first things that comes to mind is how threads interact with system calls, particularly fork and exec. Can you tell us more about that, Sheila?
Sure thing, Victor. Let's start with fork. This system call creates a new process by copying the current one. In a program with multiple threads, this can get tricky. When fork is called, only the thread that called it gets copied to the new process. This can cause problems if other threads were in the middle of doing something.
Interesting. So it's like if you're in a busy kitchen with multiple chefs, and suddenly one chef clones the entire kitchen but only brings themselves along. All the work the other chefs were doing is left behind.
That's a great analogy, Victor. Now, exec is a bit different. It replaces the entire process with a new program. In a multi-threaded environment, when exec is called, all threads are removed, and a new process begins with just one thread.
So, continuing our kitchen analogy, exec would be like completely clearing out the kitchen, firing all the chefs, and starting fresh with a new recipe and a single chef. Now, let's move on to another crucial issue, signal handling. How does this work with threads?
Signal handling in a multi-threaded environment can be tricky. Usually, signals are sent to the whole process, not to specific threads. The operating system has to decide which thread should handle the signal. If not managed carefully, this can lead to unpredictable behavior.
That sounds challenging. It's like trying to get someone's attention in a crowded room. You shout, but you're not sure who will respond. What about thread cancellation? That seems like it could be tricky.
Indeed, Victor. Thread cancellation is when we need to stop a thread before it's finished its job. The challenge is making sure the thread cleans up after itself. It needs to release any resources it's using and leave shared information in a good state. It's like trying to stop a chef in the middle of preparing a dish. You need to make sure they don't leave a mess behind.
That's a great point, Sheila. Now, let's talk about thread local storage. This is a concept that often comes up in interviews. Can you explain what it is and why it's important?
Certainly, Victor. Thread local storage, or TLS, is a way for each thread to have its own copy of certain data. This is really important for keeping threads from interfering with each other. Think of it like each chef having their own set of measuring spoons. They don't have to worry about someone else using or changing their tools.
Excellent explanation, Sheila. Now, for our final topic, let's touch on scheduler activations. This is a more advanced concept, but it's important for understanding how user-level threads and kernel-level threads interact.
You're right, Victor. Scheduler activations are a way for the user-level thread system to communicate better with the kernel scheduler. It tries to combine the flexibility of user-level threads with the performance of kernel-level threads. However, it's complicated to set up and isn't widely used in practice.
Thank you, Sheila. As we wrap up, let's recap the key points we've covered today. We discussed the challenges with fork and exec system calls in multi-threaded environments, the complexities of signal handling, the importance of careful thread cancellation, the utility of thread local storage, and the concept of scheduler activations.
Absolutely, Victor. Understanding these threading issues is crucial for creating robust, efficient, multi-threaded applications. It's a complex topic, but mastering it can lead to significant improvements in many types of software.
Well said, Sheila. And that brings us to the end of today's episode. Thanks for tuning in, listeners. Keep those threads running smoothly, and we'll catch you in the next episode of Operating Systems Crashcast.